don't know why this is out of focus. What I did to my... I don't know if I have a smudge on the camera or what. You're in void. Is that the blackness? Is that what we're... Okay. So what I'm going to do today, again, if you have any questions, please jump in and ask, or if there's topics that you'd like to see covered. Barring any of those, what I'm probably going to do is look into Excel and build some of these frequency distributions and histograms, just to give you some more insight into seeing them in action. And maybe we'll discuss more of why we might want to display the data this way. So let me see what happens when I do that. That's good. That's what I wanted. So in that data set, again, no need to follow along with it if you don't want to. But this is that week 2 data that's posted on Canvas. And let's see if I can. All right. Well, I'm going to zoom in a little bit. And so we'll walk through a couple of these. Sorry, I'm just rearranging things on my desktop. We'll walk through a couple of these, both sheets here. And again, so I think where we'll start is we're going to build a frequency distribution and a relative frequency distribution, and kind of talk about how we can do that in Excel, and then also build the histogram. So to start off, so here we have, this is actually data of all of the Marvel or DC movies that have been put out. I don't think this is fully up to date. It looks like maybe 2015. I'm gonna actually, I'll check here. So I'm gonna type equals max. And select the column C. And yeah, so the maximum value in column C is 2014. So anyway, these are movies up to 2014. So probably the last time I would have watched one. So I don't know what came out most recently, but they probably made more money than even these. But we have a variety of data here. We have their foreign and domestic sales, and worldwide, which is simply, I believe, just a total of the foreign and domestic. And then we have adjusted, which is inflation adjusted, right? So if you've taken an econ class, you know the importance of inflation, especially over time. So for instance, Superman that came out in 1978 only made $300 million, but we know that money in 1978 is worth different amounts than it is today, and so we can do some techniques that you would learn in some of your econ classes to figure out roughly what that's equivalent to in today dollars, or this is probably 2014 dollars. Yeah. So so if we're looking at this and we're thinking about Marvel and DC and superhero movies, one thing we might want to do is summarize kind of how these movies perform. And there's a number of different ways to do that, but as we've learned in chapter 2, some helpful ways are to use frequency distributions, right? And so this is a quantitative variable, so we're in the frequency distribution rather than the frequency table. Yeah, so we'll focus in on the adjusted, because if we're looking back in time, we do want to take into account inflation. We probably want to know, kind of how impactful Superman was, and put it in the same kind of inflation adjusted dollars. So I'm going to build a frequency table. I'm not. I just said I was going to build a frequency distribution instead. But again, as we've said, largely the same thing. So I'll just do that so I remind myself of what I'm working with here. And again, so as we've pointed out, the big thing I have to do here is decide what values to use. Now, for my bins, right? So I need bins, and a lot of times, and we can go back over that, we usually put an upper limit, or that's how I kind of organize it, just to help my building of that. And remember, okay, so we have to rely on a rule of thumb, or we're going to start with a rule of thumb. Remember, that is 2 to the k. We want that greater than n, where n is the number of observations. So there's a few different ways we could pick that up here in Excel, but the most simple is to know that we just have data going all the way down. And so that means we have, I guess we'll just ignore Swamp Thing because we don't have any data for it, which is not surprising because it was named Swamp Thing. So we have, this goes to 64, so we actually have 63 entries, right? Because the top row is not actually an observation. So we have 63, right? N is equal to 63. Just going to move these out of the way because they're actually where I want to put my bins. So n equals 63. We need 2 to the k to be greater than n. Maybe you remember your 2 times 2 tables or something. But Excel can always function as kind of a calculator, right? So I can just hit 2 or equals 2 to the, maybe it's the 4th. What is 2 to the 4th? That's 16. That's not enough. So equals 2 to the 6th, right? And that's 64. So that's the first time it's greater than 63. So we need 6 bins, or that's what our rule of thumb kind of tells us to start at. I'm going to go ahead and zoom in a little bit. We probably don't need to be that far out. Okay, so, and again, that's going to give us a good starting place. And as I've said, now, if you're doing your homework, the answer is 6. But in practice, the answer might fudge a little bit. And we may see that here today a little bit. So I need 6 bins, and I need to cover the whole range of data, right? Because again, I want to make sure that this is collectively exhaustive, right? Remember, our 2 big things to keep track of are mutually exclusive and collectively exhaustive. There's probably 2 L's in mutually, probably. Does that look better? I think so. And I also did not spell collectively correct. Anyway, that aside, we need to make sure both of these are followed, right? And so to be collectively exhaustive, we need to make sure that every value here has a home. And so if our bins end at, say, so this is in millions of dollars, so this is billions of dollars. So if our bins end at $1 billion, we're not going to have a home for some of these large budget or large revenue films. Okay, so it won't be collectively exhaustive. So we need to make sure it reaches all the way to the bottom and all the way to the top. So our data here is sorted by adjusted, so that's actually kind of easy to find the max and the min. If it's not, or if we want to just keep track of that, we can use a couple formulas here in Excel. So I'm going to type equals max. Okay, and this is going to look over this column and return the maximum value. And just as we expected, because we have sorted data, we knew what that was. I can do the same thing here with the minimum. And that spits it out. Now, just as an aside, I happen to know the formulas for max and min in Excel, probably because I use them quite often to do this type of just really kind of starting in on a data set. I'll type those in a lot. But what am I trying to say? People that are skilled at Excel, it's not that they necessarily have all of these memorized. Okay, you may think, all right, I know that there is a formula that lets me find the largest value, but I can't remember what it is. A simple Google of largest value in Excel will likely give you the equals max. So I just want to point that out, that it's not always just about memorizing a whole list of formulas. So don't feel like you're behind if you can't always recall which one you're specifically supposed to use. Go ahead and cheat with Google. We all do. So what do we have here? Well, I'm going to actually go ahead and calculate the range, which I think we actually will learn officially in chapter 3, although you probably mostly are familiar with it. Range is just the difference between the maximum and the minimum. So I'm going to have Excel calculate that for me, again using a formula here where I just take the value of the max minus the value of the min, and I know that I need to span I need to span 1,500 millions, or 1.5 billion. Okay, and that's helpful to know because I know I want 6 bins, but how spread out do those bins need to be? Well, they need to stretch the whole range here. Yeah, so next what we would likely do is take this range and divide it by the number of bins. I'm just going to have Excel do that for me. Again, I know I want 6 bins. So that means I need them each to span a little over $250 million. And so what I would likely do, or the place I would start, is to round that up a little bit and say, well, let's have them span 300 million. Okay, so my bins, I might want these to stretch from 0 to 300, 300 to 600, 600 to 900, 900 to 1200, 1200 to 1500, and then 1500 to 1800. I guess that would be the last one. So obviously we're spanning a little bit further than we maybe need to, but that's okay. And let's see, that's in. So I'm pausing here because I'm just double checking that I'm in the right format, or the right units, right? So a little confusing because this is in millions of dollars, so billions of dollars, but it's listed as thousands of millions. Well, my Excel is not playing well. So there's a video that as we wait for my Excel to catch up. It's concerning. There's a video that walks through specifically how we can have Excel do this with some formulas. Might need to restart my Excel. Oh, there we go. Or just minimize it. I'm sure it'll be fine from now on. Ooh. And so if you want to go back and watch that video, it uses count ifs, right, to have Excel scan over a range, and we can do a little bit of that here, but then we'll focus in on one of the kind of tricks within Excel and using what's called the data analysis tool pack. Yeah, so the count ifs allows us to search over a range, and actually the count ifs is a good way to introduce us to some of the power of some of these formulas. So I'm going to have Excel look over this range, okay, and I'm going to have it look for whether or not it's less than or equal to 300. Okay, and using that as my upper limit here. Okay, and that's all I actually need for this first one here. I don't know why I did it over there. Let's and this is going to be the frequency. Again, that's the count ifs, and we can click this whole column here. We could type in D2 to D64. That would work as well. And now so in this second one, I need to make sure that it's, yes, less than, I need it less than or equal to 600. And then the count ifs allows me to put in multiple criteria, right? So for the second criteria, again, I want it to look over the same column. And this time I want it to double check that the value is greater than 300. Okay, and I'm being specific about the greater than or equal to, or sorry, the less than or equal to, or the greater than here, because I want to make sure that each value only has one home, right? So we need to have it be mutually exclusive. And that means that if we just focus in on these first two, so think about a value or an adjusted value here that's right at 300. And I don't think we actually have one, we don't. But if we did, we would want to know which of these two bins it falls into. And the way we've structured it, it would only fall into the top bin, because that one is the one that contains less than or equal to 300, whereas this one starts greater than 300. If I were to put greater than or equal to, Excel would have no issue with that, but it would count. I'm gonna never do this. Don't ever type into your data. But if I do this, that value got counted in both. Okay, I'm gonna undo that. Because at this point, both of them are listed as including the 300. Okay, so I've just pulled down so that I don't have to retype the whole thing. We can quickly finish this out. That would be less than 1,500, greater than 1,200, and then less than 1,800 and greater than 1,500. Okay, and so we have a frequency table. One thing we can do, as we often do, is double check that we're not double counting, and there's the 63 observations that we anticipated, right? Our N is 63, so that's a good sign that we are mutually exclusive and collectively exhaustive. It's not necessarily true. We could still have issues, especially if we had issues in both directions. But it's a good sign. And if you don't get your expected N here, you know for sure you have an issue with one of these two. And then because we've built that total, we then can quickly build. I don't know if I wanted that, but we can quickly build a relative frequency, right? And again, the relative frequency is all about changing it into percentages, right? So again, with few observations here, it works all right to have it in frequency. We know that 30 is a pretty big number out of this set, but sometimes it's nice to have it in percentages. So all that is in Excel is clicking 30 divided by the total here. And now, because I'm in Excel here and I know where I'm going to go with this, I'm going to go ahead and lock this in. So remember, when I put the $sign in here, that's going to lock it so the 16 doesn't update when I go ahead and I drag this. Okay, so I'm going to drag it down one. What's changed? If you look up on the formula bar up here, you can see it was N10 divided by N16. I've drug it down and it's updated to N11, but it hasn't updated the 16 because that's locked in with the $sign. Okay, again, you could type that out for each one of these, but we probably would rather be a little speedier with it. There's a lot of decimal places here that isn't really helpful to me telling the story of this data. Nobody really cares about, it's not, 47%, it's 47.619%. Okay, so we're gonna clean that up a little bit. I've highlighted the data, and I'm right clicking here, which usually shows this menu. I see. Okay. So I'm right clicking. Let me just, I would like, we're gonna try this a little different. Yeah. Let's do that. Okay, so now I think this should show up. So I'm gonna right click here. I've got the data. I'm right clicking. Still didn't show up. That's not what I wanted. Okay, well I'm choosing format cells here, and so we can go into the format cell. I don't know why that doesn't show up. And I'm just gonna take away some of the decimal points. Okay, so that's weird. All right, and then if I pull this over, it's also going to sum here, and just to verify that I haven't messed something up, I have a full 1 or a full 100%. Yeah. And yeah, as a reminder, this I do think I'm recording. So as long as this is recorded well and captured the sound and whatnot, I will post this. So you can go back over this and pause me and reference these in the future. So there we have a frequency distribution. We have a relative frequency distribution, and as So one other thing that we learn at the end of chapter 2 is something called the cumulative distribution, or the cumulative frequency distribution. Apparently I have italicized over here. And that, again, can flow right out of this same data set. You can do it directly, but a cumulative distribution, or cumulative frequency distribution in this case, is really just the sum of all of the frequencies, or the frequency distributions up until that value. Right, and so let me give this a little more space so I can type in here. It's going to yell at me again. I don't know what that is about. So really what these bins are is less than or equal to 300, less than or equal to 600, less than or equal to 900. Okay, and displaying the data this way can be quite helpful. Actually, let me do it. So I'm going to structure my equation. So I've chosen to structure it so that it's the value right above it, and then the new frequency line. And that way, again, I can pull down, and it's going to update all along the way. Okay, so a little different way to look at the data before us, but you do see this, and most commonly, you probably see this something like, how many Americans earn less than $45,000 a year, whereas typically when we first look at, say, income data, we probably break it up into a frequency chart. But then we often discuss it in terms of less than or equal to a certain value or greater than, how many Americans earn $400,000 a year or more, or something like that. and again, you can have a relative cumulative distribution. Again, that's the same concept. Let me just lock that in so we can quickly see that. I'm going to pull this down, and it's going to give me the percentage that earn less than or equal to some value. Okay, so this is an income, but now we know that 96 or almost 97% of the superhero movies earn, this is $1.2 billion or less. And so that might be an easier way or a better way to summarize something that you want to discuss about the data. Okay, so that's the cumulative distribution. Yeah, and then lastly, to put these into histograms, again, so it takes a little, it's a little cumbersome in Excel to, and there might be a more straightforward way to do this. I want to get rid of that. Okay, so there might be a more straightforward way to select what you want. The reason I don't probably know it is because I don't often use this method. So this is, but this is a histogram of the frequency distribution that we just built. But what I want to highlight is that in Excel we can do this quicker, and we actually can build the frequency tables and frequency distributions quicker as well. I do think it's helpful for you to walk through and look at how formulas can be used in Excel. But there is kind of a shortcut. So I'm just gonna grab these bins and put them down here. And I'm going to use something called the Data Analysis Tool Pack. And I discussed this in one of the videos. I think it's the histogram video, and how you can install it on your computer, or activate it. It is I don't know, I think the right term would be it's already installed with Excel, but it's not kind of active. So the first time you'll need to activate it once, and then it should be with you the rest of the time. So it's in the data tab. Over here, I have something that shows up as data analysis. You likely don't, but you should try to get that up and going. And again, check out that video. Weird. Yeah, and maybe I'll post another video too, highlighting it when we turn to use it. Again, it's a very powerful tool. So as I mentioned in the video, Excel is a wide-ranging program, and it's not designed just for data analysis. And so some of the built-in mechanisms, especially as we've seen here with charts, are not designed just for things we might want to do in statistics. Other programs are, something like Stata or R, are molded basically for statistical methods. So we sometimes have to monkey around with things in Excel, but we've got this pretty handy tool pack that's added in that lets us do things a little quicker. Okay, so again, there's a whole host of different things here. We'll use descriptive statistics in the next couple chapters, and by the end of class, we'll be doing regressions. Some of this, you can't see this. I do not know why that's not picking up. Let me see. Sorry about this. Window capture. It should. I'm learning technology. Okay, this might get, there we go. That's what we want. Okay, It's going to be a whole new experience here. Okay, so I'm going to click into data analysis here. There we go. Okay, so this little window will pop up, and as I said, there's other options in here that we'll use heavily the rest of the way, descriptive statistics. But we're going to turn to histogram, right? That's the thing we're trying to build right now. I'm going to click OK. It's going to give me a menu here, and it wants me to fill in. Apparently, I was already... Nope, that's a different one. So the input range. So remember, when we're building it ourselves in Excel, we have to go through the kind of process of building all these bins and stuff, and doing the count ifs. So here, I can go ahead and select my actual data. I don't have to do it myself. My bins, I do need to select the bins or build the bins. Okay, so I'm gonna grab, actually gonna grab one above, so I can put a label there, and then I'm gonna have it spit the values out here, and I want to click chart output. Okay, and so this has been what, 6 or 7 clicks, and we're gonna get a working histogram somewhere on the page. Is this? Yes. And so here is the histogram and the frequency distribution in just a matter of seconds, instead of spending all of that time building all of this stuff up here. Okay, so in practice, if you want to build a histogram, it's best to get familiar with this data analysis tool pack. We can adjust things in here. We don't actually need this thing that says frequency. I'll probably get rid of this more. Okay, so the tool pack builds in kind of a greater than kind of overflow bin. Another nice thing about this is that we can quickly update what the labels are here. Yeah. So, and then we'll talk more about little things you can do in Excel as far as visualizing it. Maybe I want these crooked to fit more space in there. All kinds of things you can do like that. Okay, and so there we have a histogram. Again, I say that this is the rule of thumb. 2 to the k is kind of a starting place. Perhaps you want to try it out, and with the data analysis tool pack, it's a lot easier than having to rebuild all of those count if statements. If I want to look at what it looks like if I build my my histogram with, say, an extra bin, right? So now, maybe 2 extra bins. So maybe I want to see what it looks like with 8 bins instead. I can quickly do that. It'll be the same input data, but I'll change my bin range. And let's put it out down here. And there. So now we can kind of compare. Again, what we're trying to do is tell the story of our data. So that's a decision that you'll kind of have to make as far as, you know, in practice, which of these charts gives you more information. You know, the difference between 6 and 8 bins is probably not a lot, but you could imagine if we tried this with you know, 600, 1200, 1800, that's likely. We can take a peek at what it looks like too. My guess is we'll be a little underwhelmed with the kind of quality of the output here. I mean, yeah, so we're not learning a whole lot, other than most of them fall below 600 million. But I think we'd prefer a little more nuance in our display. Yeah. Okay. So that was me flying through a lot of stuff there, and then I know for people that are new to Excel, what I was doing was probably a little quick. But so hopefully, if you do have questions, you can go back and peek at this, and maybe play around with the data yourself. Okay. So let me just take a pause and see if there are any questions before I'm going to jump over to some other data if there aren't. actually, before I jump over, we did build this cumulative frequency distribution, and so it's probably worth inserting a little, trying to build a frequency or cumulative polygon. So let me see if I can actually, what it'll do. Yeah, Excel likes, it does not like to default to what we would prefer it to default to. Let's see. Well, I don't know the best way to go about it in that regards, but I do think if, bear with me for a minute, I think if we go into the histogram and let's grab, let's go back to our original kind of 6-bin situation. Actually, let's grab that, and we'll output it up here. And I'm going to do cumulative percentages and just see what happens here. And sure enough, actually, in this case, it's given us both. But we can see the cumulative polygon showing up here. Okay, so and if we wanted to really focus in, we could probably do that and not include the frequency. But you can see the orange dots here building the cumulative frequency distribution. And in fact, let's try that without. I don't know if that's gonna. Yeah. So apparently it wants to put them both on the same chart. So we could remove that. There. So now we can see that classic cumulative frequency distribution. Okay, and building that in Excel is a little cumbersome, but this is that view of things that lets you, just like we talked about, wanting to talk about, say, an income thing and saying how many Americans or what percentage of Americans earn less than $70,000 a year. Same thing here. Now it's more straightforward to talk about what percentage earn, or of the movies earn less than 900 million. We can format this axis. We do not need it to go to 150% because that doesn't make a whole lot of sense. So it might look better in that regard. Yeah. Okay. So also we managed to get there in Excel. Again, not as straightforward. Okay. So I want to just run through a little bit more. We'll look at some more data with this in mind. So I have here a misspelled, it should say college, but it says sellage. And this is the data I wanted to look at. But again, let me just pause. Are there any questions or concerns you're having at this point? Okay, so here I have there's 200 and some. These are probably all the Division 1 schools or were at some point, and they're college athletic departments. It's clearly not from this year because I don't think any of them are making that kind of money. But yeah, I think this is a couple years old now. But one thing again we might want to look at is let's focus in on their revenue. Obviously, we can see just from scanning that there's a lot of them in between 10 million and 70 million. But how exactly does that kind of fall out? Well, again, we can use this frequency distributions and histograms to get a better feel for that data rather than just saying, I don't know, there's a mix match of things. But when we do that, we do need to build the bins ourselves. Okay, that's a decision we have to make. So again, what I'm going to do is I'm going to look for the max and the min, and then eventually the range, right? I do want to know that. So I'm going to use that equals max and look over the total revenue column. Somebody's got 196 million equals min 3 million. Okay, so maybe not a completely even playing field. And so we do need this data to, or our bins to stretch 192 million. Now, in reality, we probably want to stretch from probably 0, just to make it easier to interpret, from 0 to say 200 million or something. We need to know how many bins, right? So we're new data, new n. We have a different n that we're dealing with. So n is equal to what? It's we need to find out how many are down here. Now, we could quickly scroll down here, but I do want to just let you in on a little trick. When you're moving around in your data, you can use the arrow keys. If I want to jump somewhere in the data, I can hold down Control and hit the arrow key. So I'm going to hold Control and I'm going to hit the left arrow, and this should bring me over to where it says Arizona. And if I hit Control and I hit the right arrow, it'll bring me to that 94,000. Oh, it did not bring me there. It brings me to the next space in the data, and then I can hit it again and jump over that, hit it again and again. Okay, so Control lets you jump around quicker in the data. I can use that to my advantage here because I can hold Control and hit down, and it's going to go all the way to the bottom of the data. Okay, and I can just double check there's no data below it. And so now I know, so there was 231 here. So let me jump back up. The top one is not a value, so I actually have an n of 230. Okay, so that's helpful information because, again, that's going to give me a starting place for the number of bins, right? And I can use Excel 2 to the, we just did 2 to the 6th. That's not going to be enough. So 2 to the 8th, I think, will. 256, so that covers my 230. So I want, or I'm going to start thinking about 8 bins. And remember, I want to stretch from a little bit below to a little bit above. You probably are already able to see where I'm likely going with this. So something like 0, 25, 50, 75, 100, 125, 150, 175, and 200. All right, so that might be a good starting place as far as our bins go. But we are in millions of dollars here, so I don't actually need that bin, do I? So I'm going to actually, let's see, let's do this times. Okay, how many zeros do I need? I need this times 1,000,000. And I'm going to drag down, and that should give me all those bins. And then I'm going to right click just to double check. I want to format this so it's in basically I want the commas. So I'm going to make it into a currency, because why not? And I'm going to take away the decimal points. I don't think we're really care about the 15 cents that some university might have for the collegiate budget. And there we go. So these are a good starting place of bins. I'm going to copy this. So, well, I can just use it directly from that. Okay. So now, rather than go through that whole process of count ifs, I'm going to jump directly to the data analysis, do a little histogram. My input data, I want to focus in on total revenue. My bin range, I'm going to grab one above and pull down. Now, the reason I'm grabbing one above is because I have grabbed all of column C, which means I have a label. So I want to make sure that Excel is counting this blank one as a label as well. And I would just want the chart output. I don't really want the cumulative situation yet. And let's output it. Let's just put it right below. Actually, we'll put it over here. And there we have a histogram. Okay, whoop. And so we can see, rather than, you know, initially when we scanned through the data, we said, there's a bunch more than 10 million. There's some upwards of 100 million. Now we have that broken down a little bit better. We can see just how many of them fall below 25 million is pretty, a lot of them. The first thing, so we don't need that. I would probably start to update these. So I might put these back as the 25, 50, 75, 100, right? And that's going to automatically update on here. Another benefit of using this method. And then we can go ahead and expand that a little bit. And then I would want to add a label here. Where did my... I don't know where my axis label went. Oh, axis titles. There we go. Oh my. Too many clicks. Okay, and I would want to have this be total revenue in millions. Okay, I don't want to lose track of the fact that this is not just $25, it's 25 million. So I realize that's very small on your screen, probably. Let me just expand that and mess it all up. Okay, so this is obviously much more helpful. One thing I do want to point out, and this does happen in especially things regarding money. Here we have a lot on the low end, and then a few outlier, or a few on the kind of extreme end, right? We have a few universities here that are making more than 150. We can take care of that, or we can choose to show this a little bit differently if we kind of use an overflow bin or greater than or equal to some bin, and don't kind of cap the end. You know, you'll see this again going back to income. You know, we might want to zoom in and look at the incomes of Americans and range that from in the 10,000, 20,000, 40,000, and so on, and then kind of have like, okay, let's lump all the millionaires together in a greater than 1 million or something, rather than have to stretch it all the way out and say, oh yeah, and we need a bin for Jeff Bezos over here at whatever it was. So how do we do that? Well, we can think about how we're building our bins. And maybe instead I want to build my bin as let's try like 10. We could go to the extreme of 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and then something like greater than 100. Okay. Again, we need this to be times 1. What do we need this times? 1 million? Is that what we decided? So that's 10 million up to 100 million, and then we will leave that last one as a more than. And so when I go back in and I do my data analysis, histogram, it's the same input data, but now I'm going to grab this set. Let's have it pop it out down here. And now we're a little more focused in, or kind of zoomed in, looking at the data on the lower end of the situation. See if I can might be able to just plop that in there. Okay, and then this is you know, greater than 100, perhaps. Okay, and so that's a choice you'll have to make, you know, when you're looking at data like this, in how again you want to tell the story, and you can see that this lets us examine kind of the heart of our data more so than the one up above. But we do lose a little bit of that nuance, right? So now all I know is that a chunk of them earned more than 100 or had revenues higher than 100 million, but I don't know, which I do up here, that some of them were almost to 200 million. Okay, so I lose some information there when I choose to focus in on the lower end. So there are trade-offs, but visually we'll have to make those choices as far as what we want to visually showcase. Again, we want to make sure that we're typing out something like that to remind ourselves of the units here. Okay, and notice, well, so that might have been the same number of bins. It might be more. I think I have more bins here. Again, that the bins are kind of a place to start. Yeah, so just kind of a rule of thumb to get you started. That, what did we decide? 8. But here I must have 11 of them. So, yeah. Trying to think if there's any other yeah, I think that's all I kind of wanted. I know this was a lot, and we flew through a lot of Excel, so it's understandable if you were a little lost on what buttons I was exactly clicking. But hopefully, if you do want to go back and peek, you can do that. At some point, it'll probably be. I'll probably wait another week for another problem set. But I probably will have you build a histogram. So at that point, you'll probably be forced to go back and look at what I did. Yeah. So unless there are other questions, I think we'll stop now and yeah. So feel free to. I'll stay on here for a bit. If you do have questions, otherwise feel free to shoot me an email. And yeah, as a reminder that Connect assignment 2 is due Sunday night. And yeah, and then I sent out an email reminding you or kind of giving you a heads up that chapter 3 is more intensive, and there's more math involved, and specifically, and so I wanted to bring that to your attention so that you're not rushed on it, or if you can at all, kind of start looking into it a little bit, because standard deviation ends up being extremely important for what we do the rest of the way. And it's that topic that I warned you that it may not sink in right away the first time you read it. So if that's true, that's okay. But we do need to start kind of trying to wrap our heads around what it's telling us. Yeah, just a little heads up that next week might be more time consuming for you with regards to this class. All right.